All right, good morning, everyone. I'm just going to come up with some problems for us to do. I don't have a worksheet for us, so. Okay, let's start off with curve sketching. Let me see, hold on. Okay, let's try this. Okay, gather all the information that we need. X becomes 1, 2 sine x becomes 2 cosine x. Set f prime equal to 0. I'm sorry, 2 cosine x. We're going to change right back. Okay, cosine x equals 1/2. First and fourth quadrant. But we want something inside the interval, so 5 pi over 3 is too far outside. We can always subtract 2 pi to see if we have anything that is in the negative region.
We don't keep going.
We don't, because 5 pi over 3 is already past. It's already past my interval. So, but I want to go in the negative direction to see if something lands in the negative direction. So negative 5/3 is to the left of negative 1, so we know this one is out. But negative 1/3 is between negative 1 and 1, so this is good, right? Are you okay with that? Okay there. Okay, so here's my f prime sign line. Okay, we choose values in each subinterval. Between negative 1/3 and negative 1, I can choose negative 1/2. Okay, between negative pi over 3 and pi over 3. And between pi 1/3 and 1, we can choose 1/2. Okay, let's test these intervals here. So I'm going to put negative pi over 2 into f prime. Test this against f prime. Negative pi over 2 is same thing as 3 pi over 2, right? I can always add 2 pi to make it inside the interval that we recognize. So cosine of 3 pi over 2 is going to be 0. 0 times negative 2 is negative 2. Or 0. 1 minus 0 is 1, so positive. Positive slope. Cosine of 0 is 1. 1 minus 2 is negative. Cosine pi over 2 is 0. 1 is positive. Okay, questions so far? Okay, we'll come back and gather the order pairs later, but let's move on to second derivative. Okay, 1 goes away to 0, cosine becomes negative sine. Okay, so where is sine equal to 0? 0, pi, 2 pi, negative pi. Okay, just listing out all the values for sine of 0. And we only want the ones between negative pi and pi. Only 0, right? Back to the second derivative. Okay, negative pi over 2. Same thing as sine of 3 pi over 2. That's going to be a negative. Negative 1 times 2 is negative. So negative is going to correspond with concave down. Positive. Okay, we're done with the calculus. We know intervals of, we know there's a point of inflection at 0, and we know where the relative max and relative mins are. Okay, so let's go back and gather information and sketch the graph. When we sketch the graph, we're going to go back to the original function and gather all the order pairs that we need. So endpoints, relative max, relative min, those are the important ones. Maybe we can also find points of inflection just for practice. Sine of negative pi is the same thing as sine of pi, so that's going to be 0, which is left with negative pi, which is around -3, right? Okay, let's also find the order pairs at our relative max and relative min. Okay, if you don't recognize sine of negative pi over 3, that's the same thing as sine of 5 pi over 3. Or we can always add 2 pi to make it more familiar. This is in the fourth quadrant. The negative two negatives become positive. And we know that root 3 is around 1.7. I'll give that information to you on the test. So 1.7 divided by 2. It's around, what, 8.9. Okay, so really close to 0, but a little bit under 0. Okay, the other relative extrema is at pi over 3. Yes.
In the last one, where did 2 go?
Oh, yeah, I need to include that too. Sorry about that. Thank you. So the 2's cancel out. So I have -1 plus 1.7. So more like -0.3. Like 1.7, right? Sorry, 0.7. Just 0.7, right? Okay. Sorry about that. Thanks for that catch. Okay, so sine of pi over 3. This time, sine of pi over 3 is going to be in the first quadrant, root 3 over 2. Okay, let's also find the order pairs at the point of inflection. Point of inflection is at 0. Which is 0. Okay. Okay, let's sketch our graph. Going from negative pi to pi. Okay, negative pi is going to be all the way down at negative 3. Pi is going to be at 3. Negative pi over 3. It's going to be at 0.7. Pi over 3 is going to be at negative 0.7. And then there's point of inflection at 0. Okay, so we know how the graph is going to move. It's going to rise until negative pi over 3. It's going to fall until pi over 3. And it's going to rise up until we reach pi. Okay. No information about the curvature yet. We just know how the graph is rising and falling. Any questions here? Okay, so now we give it the curvature information. We know that the graph is going to be concave down until 0. And it's going to switch back to concave up. Okay, so concave down first. And it switches back to concave up.
Sorry about that.
So you're also going to be responsible to find intervals of increase, intervals decrease, relative max, relative min, because statements, concave down, concave up. But I'm going to skip that. I feel like those you know how to do. Rather focus on something else. Okay. Okay. So here's the curve sketching problem. For those of you who are late, I'll leave this up on my table here. If you want to come up and you can take a picture of it. Okay. Okay. So there's the full curve sketching problem. Any questions? Okay. I'll leave this here. Guys, this is off of worksheet number 1. You'll see a problem that deals with average rate of change, mean value theorem. So I want to just kind of go through this again so that you guys have this fresh in your mind here. Okay, average rate of change, average velocity. All this is just finding slope between endpoints. Okay. Okay, so before we define slope between endpoints, we first have to find order pairs. Secant cubed t over 6, I'm going to rewrite this in a manner that's easier to think about. You can also pull any fraction out in front of the variable, right? I can make this 1 over 6 times t as well. All right, if you don't want to deal with fractions, you can always push it out in front if it makes it easier to look at. Okay. Between 0 and 2 pi. Secant of 0, we know it's going to be the reciprocal of cosine of 0. Cosine of 0 is 1. If you flip 1, you still get 1. The secant of 0 is going to be 1. Two pi over 6 is pi over 3. Secant of pi over 3 is same thing as, well, first off, you can think about cosine of pi over 3. Cosine of pi over 3 is 1/2. If you flip 1/2 around, you get 2. Two cubed is 8. 8 times 2 is 16. There you have your order pair, right? So average rate of change is just change in y over the change in x. We don't. Why is that? There's no derivatives involved, right? There's all we're doing, average rate of change, just slope between endpoints. There's no calculus. Now, part B, when it says for instantaneous velocity, then we're moving to the derivative and then a chain rule will be involved. Right, so understand that when you do slope between endpoints, there's no calculus. You're just plugging in endpoints and just finding slope between endpoints. Okay. Okay, are we okay with average rate of change? Part B. Find when the instantaneous rate of change I'll abbreviate as ROC. Instantaneous rate of change is equal the average rate of change. So this is really spelling out mean value theorem. Mean value theorem, you have the slope between the endpoints, you have the derivative, and you set them equal to each other. Okay, so here's mean value theorem. We basically did average rate of change here, and now we're going to move to instantaneous. So instantaneous means I need to find the derivative. So again, here's my original function. Okay, to find the derivative, I have to go through. Now I can use what? I want to find the derivative. So now it's chain rule, right? Now we got to deal with outside, inside, inner. Okay, outside's derivative, bring down the go through power rule, 6 bracket squared. Keep the inside intact. Times the inner function's derivative. Sorry, inside function's derivative. Secant becomes what? Secant tan. Multiply it by the innermost function's derivative. 1/6t becomes 1/6. Okay, do a little bit of cleanup here. All this is being multiplied, so I can rearrange however way I want to. 6 and 1/6 can be taken out. We have like terms here. Secant squared and secant can be merged to be secant cubed. It just says set up the equation, so we're going to set up the derivative equal to the slope. Part C says find the instantaneous rate of change at t equals pi. So how do I find the instantaneous rate of change? Plug into the derivative, right? I want to find the instant slope. Let me do f prime of t first, then we can plug in. Well, let me rewrite the derivative first, and we can plug in. Okay, so there's my derivative. If I put pi in for t, okay, pi over 6, secant of pi over 6. We can think in terms of cosine of pi over 6. We know cosine of pi over 6 will just be root 3 over 2. So just have to flip that around, right? That means secant of pi over 6 must be 2 over root 3. Tangent of pi over 6. Tangent of pi over 6. Be 1 over root 3. Okay, 2 cubed is 8. Root 3 cubed is root 3 times root 3 times root 3, which will be 3 root 3. Multiply this together, root 3 times root 3 is 3. 8 over 9. Okay, so this is yeah, we just did worksheet 1, number 4. Okay, any questions with that? Okay, let's do an inverse trig derivative and an implicit differentiation. Okay, give that a try. Well, let's so take a look at that for a moment. What process is involved if we want to find this? This is both. This is this is a trig derivative. What else is there? There's also implicit. Okay. So there's implicit differentiation because you have y's all over the place. What else do you see? Product rule, right? Just with this. Okay. Obviously, we have a trig derivative. We have derivative for e to the u, and then arc trig as well, right? Okay, spend a minute there. Try that. I'll be right back. I'm gonna pull something from the top here. Okay, so product rule. Oh, this is messy. Sorry, guys. Let's see. Yeah. There shouldn't be a y there. Makes it ugly here. Let's make that x. Sorry about that. Sorry. I can make that x instead, guys. Okay, so y squared becomes 2y dx. Fg prime secant of u. Secant u becomes secant u tangent u times u prime. E to the u becomes e to the u times u prime. 3 pi x becomes 3 pi. Equals to, our tangent of u is u prime over 1 plus u squared. So u prime, what's 3y's derivative? But we're asking for y's derivative as well, so yeah, dy dx. 1 plus u squared. How about 4 pi? 0, good. We have 4 individual terms, and we want the dy dx terms together on the same side. Because what's 4 pi's derivative? Just 0, right? So I could have just left that out. I just want to make sure that we understood that we did take its derivative and we made it go away. Merge, I like to put the coefficients in front, so 2y squared, this will go to the other side. Okay, good so far? Any questions so far? All right, factor out the dy dx. And divide the whole parentheses over, get dy dx by itself. Okay, any question with this? Okay, I'll put this up at the front of the front table. You guys want to Okay, I got a related rates problem for us here. As I'll copy that down. Okay, model rocket is launched 30 feet from Maria and is rising vertically at a constant rate of 20 feet per second. But the rocket has an elevation of 40 feet. How fast is the angle of elevation from Maria to the rocket changing at that moment? Okay, the rocket is launched 30 feet from Maria. We know that this distance is not going to change, but we know this is changing and we know this is changing. So I'll call this 30. And we know that y is changing as well. Okay, so just based off of what's given to us, we have to rely on a trig equation that's going to hit all three parts. Which one do we use here? Sine, cosine, or tangent? Tangent, right? Because we have opposite and adjacent. You can either go through quotient rule. Yes, question? Any questions? Okay. You can either go through quotient rule, or you can push it out in front as what? 1/30y, which really just requires us to do power rule, right? Just push that coefficient on in front. Okay, let's find the derivative. Tangent's derivative is we're dealing with related rates, so we also need to include what? 1/30th y becomes dy dt, right? Time is our independent variable, so everything has time involved. Okay, let's gather some more information from the problem here. Rocket is rising vertically at a constant rate of 20 feet per second. What is that assigned to be? Positive, right? When the rocket has an elevation of 40 feet, so we know this is a moment in time, but this moment in time is going to be helpful. So y is 40. Okay. How fast is the angle of elevation changing? What are we looking for? So if we look, we have most everything that we need, right? dy dt, we have that. 20 d theta dt is what we're looking for. The only thing that's standing out is we need to resolve that secant squared theta. Okay, we're not going to replace theta. We're going to replace the entire trig function, right? Replace the entire secant theta. So to do that, we're going to go to our another triangle and see if we can fill out all the sides lengths for this moment in time. Okay, this moment in time, this y is what? 40. I can find the missing sign by using Pythagorean theorem. A squared plus b squared equals c squared. This is also a variation of the 3, 4, 5 triangle. So we want to find a replacement for secant theta. What's secant and theta going to be here? What's the ratio? Okay, we know secant is related to cosine, right? Cosine is adjacent over hypotenuse. So therefore secant is hypotenuse over adjacent. And what does 50/30 reduce to be?
5/3.
5/3. Okay, so we have everything that we need here. 5/3. Make sure we square that. dy dt is 40. Now we just want to clean everything up, right? Try to move everything over. (40/30) reduces to be 4/3. And now what's the last step here? Yeah, multiply by the reciprocal, right? We do a little bit of cleanup here. 9 and 3 can reduce. Oh, I messed up here. dy dt should have been 20. My bad. I put 40 here. Threes cancel. 9 and 3 cancels out. And 2 times 3 is 6. 6/25. And what's the unit of measure? Radians per second. Okay, why don't we do this as the last thing here? See if you can recall your derivative rules. Write those down.
Should circle one of these type of problems. I very study and I was trying to figure that out with just like an example of each kind. To kind of review over.
Yeah, those are the big ones.
So that's about
That's about
all you really study. Yeah, I've got
Start making these negative versus making it positive because it depends on the intervals.
Depends on the interval, right? So once you find 0 and pi, you can either add and subtract 2 pi to get variations of this. We just want to know what variations is going to land inside the interval. Guys, I need all your foot bags up in the front.
This term over there, or outside this term over there instead of that one. Like I had to.
Yeah, your size different, but that's the same.
Was this the answer for this?
Mhm.
Okay. So you don't go any further, you don't have to like solve for t.
Not for this one because it's too complicated.
Will it be like that on the test? Or?
You might have to solve.
Are you ever like the U derivatives and stuff like that? Like E to the U or something?
Yeah, the whole thing to the U.
I thought I could.
And then the 6 arc trig rules. You go with these. And then the original 6 derivative rules. So, Andrew, you got the 6 derivative for trig, 6 derivative for arc trig, and then these 2.